Okay, we are going to do a quick review unit or review couple days over slope. You guys should know some foundational concepts about slope and how to find slope and how to use slope and what slope actually is. So this is going to be a quick tutorial just to go over finding slope and what slope actually is. So in these little rectangle kind of things down here, I have different ways that you can find slope. And so we're going to go through each of these fairly quickly. And this is a picture of my son Camden with the Snapchat filter on. He says, what's slope and how do you find it? All right, so let's figure this out. Finding slope. So let's first talk about what slope is. So slope is also called the rate of change. So anytime you are asked what the rate of change is, that is slope. We see slope on a graph, but it's the rate of change. It's the rate that the graph is changing. It's the rate that the points are changing. And anything can have a rate of change if it is changing. And if it's a constant rate of change, that's when we get a line. If it's not constant, that's when we would get something that like goes up and then down, or maybe curves a little bit because it's slowly increasing then slowly decreasing. But if it's a constant rate, then it's going to create a line. So think of like your bank account. If it's at 0 and you make $10 an hour, the first hour it would go to 10, the second hour it would be at 20, the third hour it would be at 40. So that rate of change is $10 per hour. The rate of change is 10. It's 10 over 1, $10 per 1 hour. So the slope of that, if we graphed it, would be 10 over 1, which is just 10. So the way that you see this on a graph is you see, you might see a triangle in Y and a triangle in X. And what that means is the change in Y, how much is the Y changing over the change in X? How much is the Y changing? How much is the X changing? How much am I going up and down over how much am I going left or right? So this is the rate of change. It's how much you're going up and down or left and right. And we'll talk more about that here in a few minutes. If we want to find slope, sometimes we're going to find it from a table. Sometimes it'll be from an equation. Sometimes it'll be from a graph. And sometimes it'll be just from 2 points. And so we're going to go over those quickly. So if we're looking at finding slope from a table, we just learned that slope is actually how much the Y is changing over how much the X is changing. And that little triangle, again, just means change. Change in Y over change in X. So when we look at this table, we want to see how much it's changing each time we increase our Y values. We're not looking from X to Y. We're not looking there. We're looking how much is our Y changing each time. So from -2 to 2, that's a change of going up 4. From 2 to 6 is 4. From 6 to 10 is 4. From 10 to 14 is 4. This tells us that we have a constant, we so far are on a path of constant rate of change. So the change in Y consistently is +4. Over here on the X, we want to see how much is it going up or down each time. So from -2 to -1, that's an increase of 1. From -1 to 0 is an increase of 1. From 0 to 1 is an increase of 1. And from 1 to 2 is an increase of 1. So it's a constant change as well on the X value of 1. So how much is it changing in my Y value? It's going up by 4. How much is it changing in my X value? It's going to the right 4. So this slope is 4 over 1, or we would just say it has a slope of 4. Let's go over and see what it would look like from an equation. So the most of the time you are going to see is called slope-intercept form. So if we have y equals mx plus b, this is called slope-intercept form. Slope-intercept form. And the reason that it's called slope-intercept form is because it's written in the slope and the intercept form. So you don't have to do any math, you just have to know and memorize that the slope is before the x, and the intercept, the y-intercept, is afterwards, is being added or subtracted. So when I have y equals mx plus b, this number right here, whatever this is, plus, minus, or positive, negative, it's a decimal, a fraction, whatever it is, this is your slope. This right here, positive, negative, fraction, decimal, whole number, whatever, is where your graph would hit the y-axis. It's called the y-intercept. So one of the biggest things you want to know is this is slope-intercept form. You have your slope right here before the x, and you have your intercept afterwards. So let's look at a quick example really fast on here. If I have y equals 4x minus 2, I know that my slope is right here before the x, it's 4, and my y-intercept is after that, whatever, plus, minus, whatever, my y-intercept is negative 2. If I were to graph this equation, it would hit the y-axis at negative 2. The next point on the line would be up 4 over 1, up 4 over 1, up 4 over 1. The slope is like the directions. And we can even write that up here in this box. We can write the directions from one point to another point. So if I had a coordinate graph, coordinate plane, and I had a point right here, and I said my slope is 2/3, that means I'm going to go up 2. So maybe I go up 2, and then I'm going to go over 3. And so my next point would be right here. I went up 2 and over 3, and so I could connect those two dots, and that would be the graph of that line. So it's directions from one point to another. Let's look over here at if we have something on a graph. So I'm given this line on a graph, and the first thing I know for sure is that because it's going up like this, I know that this is going to be positive. This is going to have a positive slope. When I'm trying to find slope from a graph, I just want to pick 2 points that are on that graph, and you want to make sure it's exact points, so maybe right here and right here. And you want to find the directions from the left point to the right point. So from the left point, I'm going to go up 1, 2, 3, 4, and I'm going to go to the right 1, 2. So my slope on this one is 4. Oops. My slope on this line is 4 over 2, which simplifies to 2 over 1, which is actually just the slope of 2. If I wanted to write an equation for this line in slope-intercept form, it's mx plus b, right? And we know this m right here is our slope, and so I just found that out, so it's going to be 2x. And where does this hit the x-axis, or I'm sorry, the y-axis? It hits it at 3, so I know that it's going to hit at 3. So this would actually be the equation to this line, 2x plus 3. All right, let's look at this line. Just like the one right above it, it's going up. If we look from left to right, it's going up. This one, if we look from left to right, it's going down. So this is going to definitely be a negative slope. Knowing that this is negative just by looking at the graph will help you, because if we have a multiple choice question or you're asked to find the slope and you're given options, any positive options you know just aren't right because this is going down. If you look from left to right, it's going down. So this is definitely a negative slope. So again, to find that slope, let's just pick out 2 points on the graph. And we want directions from the left to the right. So from the left point, I'm going to go down 1, 2, 3, 4. And I'm going to go over 2. I went down 4, so that's negative. That's where you get the negative. So I went down 4 and over 2. Oops, sorry. I went down 4 and over 2. So my slope on this one is negative 4 over 2, which is the same thing as negative 2. If I wanted to write the equation to this line, I know I have y equals mx plus b. This letter m right here is my slope, so I have negative 2, and my y-intercept is up here at 3. So now this is the same line, it's just negative, so it's negative 2x plus 3. Okay, let's look at this line right here. Anytime that you see a horizontal line, this has a slope of 0. Remember that the top number of our slope, our numerator, is how much the y is changing. Well, if I go from this point right here, and I find another point right here, how much do I go up and down? Well, I go up and down 0. How much do I go to the right? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 spots over. So 0 over 8 is 0. That's why this has a slope of 0. Let's write this in y equals mx plus b. Well, I know that my slope is 0, so 0 times x, and my y-intercept is at 1, 2, 3, 4, 5, 6. Because this is 0, I don't need this, right? 0 times whatever is still 0. So the equation for this line is actually just y equals 6. All of my y values are 6. Okay, one more. When you have a line, and it's kind of hard to see on this one, but it's right here. When you have a line that is going straight up and down, this is called undefined. So this graph has an undefined slope, and here's why. If I were to take 2 points on this graph, right here, I am going to go from the left to the right. We just pick one there on top of each other. I'm going to go 1, 2, 1, 2, 3. So I went up 3, and I'm going over 0. Well, we cannot have a 0 on the denominator. We cannot have a 0 on the denominator. So this is why this is an undefined slope. So if you ever have a multiple choice question and you say, what is the slope of this line? And you're given all of these numbers, and then one of the choices says undefined, that would be it. This is considered an undefined slope because the rise over run, the change in y over change in x, the change in x is 0, and we can't have that. And that's another good thing to add up here to the top. So we say that the change in y is called the rise, and the change in x is called the run. So you might hear someone say rise over run. Rise is the change in y. How much are you going up and down? Run is the change in x. How much are you going left and right? Let's look really quick if we are given 2 points. So if I have the 2 points, 1, 2, and negative 3 and 5, let's find the slope of these between these 2 points. So I know that I want the change in y over the change in x. So this is y2 minus y1, x2 minus x1. This just means the second y value minus the first y value over the second x value minus the first x value. So it's helpful to label these so we know what we're working with. So we're going to take our y value minus our other y value, our x value minus our other x value, and simplify. 5 minus 2 is 3. Negative 3 minus 1 is negative 4. So our slope is negative 3/4. So this line on a graph is definitely going down because it's negative. So this has a slope of negative 3/4. And if you think about where these coordinates would be, I have coordinate 1, 2, so maybe right here, and my other coordinate is negative 3, 5, so it would be up there. So that makes sense. Okay, so all of that is finding slope. So let's look at using slope. When you know how to find the slope, you are given a point on the line. You can graph the line. Remember, slope is how many spaces to go, we're going to say up or down. Then, how many spaces to go left or right. Remember, we are talking about rise over run. Make sure we get that in our head. Rise over run. That will help you remember it. Let's look over here. Graph the line that passes through 1, 2 and has a slope of 3. Well, we know that any number by itself has a denominator of 1. So this slope, in a really an easier way to see it, since we are talking about rise and run, is to say that this has a slope of 3 over 1. So let's plot this first point. We're at 1, 2. So our first point is at 1, 2. So I go over 1, up 2. Remember that the point 1, 2 says that my x value is 1 and my y value is 2. It's like in the alphabet, x becomes before y, so it's our xy value. So this point 1, 2 has a slope of 3 over 1. What that means is the y value is going to change by 3 and the x value is going to change by 1. So to find the next point, we're going to go up 3, and then we're going to go over 1. So that would be the next point on my line. We can also do the opposite sign of both to find a third point. So if I was going up 3 to the right 1, I can go down 3 and then to the left 1. This is an L for left. So let's go down 3, 1, 2, 3, and we'll go to the left 1. So this is our third point. And so this is great because it makes a perfect line. So we can draw a line right through these 3 points, and that is the point of, or that's the line of the graph that goes through point 1, 2 and has a slope of 3. What did you notice here, over here, what the y-intercept was? The y-intercept was down here at -1. So this y-intercept was -1. So if I wanted to put this into y equals mx plus b, my slope was 3, and my y-intercept was -1. So this would be the equation of the line that goes through point 1, 2 and has a slope of 3. Okay, let's try this very last one. Actually, why don't you graph this one and you can check your answers in class. That way I have something to see if you fully understand. If you feel like you struggled with this, just go back up to that one and see how I did it. Go back to the page before it and see if that's helpful. But try this one on your own, and then I will check it when I sign off on your notes. Good luck.